All right, number 3 on the vertical motion models assignment. A punter punts a ball at Dallas Stadium from his own 30-yard line. If the football leaves the punter's foot from a height of 5 feet, has a velocity of 80 feet per second, will the ball hit the jumbo screen hanging from the top of the stadium that is 150 feet high? All right, in order to do this, what you need to do is, first of all, write down the model. H equals what, guys? Plus S. All right, we got to fill in. Okay, remember, H is the height at the end of the story, right? V is the initial velocity, okay? And S is the starting height or the initial height. So the thing that can be a little bit confusing is that H and S are both heights. But remember, H is the height at the end of the story, and S is the height at the beginning of the story, the start. Okay? So, here's the thing. We don't have a height at the end of the story because this one is a little different. This one we're talking about a maximum height. In order to find the maximum height, what you need to do first is find the axis of symmetry. We're going to get to that in just a second. First of all, what was the initial velocity, guys? What was the V? 80. So I'm going to put H equals negative 16t, squared, plus 80. That is from the word problem right here. 80t, and then plus, what was the initial height?
5 feet.
5 feet. I think this is a really tall football player. Okay, so he's drop kicking the ball, and let's see. Okay, so in order to find the axis of symmetry, then what you need to do is you set it up t equals the opposite of b over 2a. Alright, so this is the time when the ball will be the highest. After you find this time, we're going to plug it back into this function right here to find the actual height. I'm getting puzzled looks. You guys like, I don't know what you're talking about. Right? Okay, let me show you a little drawing. If you have, this is like the height versus time for a punt, right? And the axis of symmetry is kind of like this line right here. So the highest point is going to be right here, right guys? So what we're trying to do first is we're trying to find the time when it hits the highest point, and that's what this is right here. Okay? Then we're going to actually find the height afterwards. Whatever this value is, we're going to plug it back in. It'll make more sense as we do it. Alright, what is the opposite of B this time? Remember, this is A, this is B, and this is C.
Negative 80.
Negative 80, very good. And 2 times A, what is A?
Negative 16.
Very good. Now, you guys know that a negative divided by a negative is a?
Positive.
Positive. Alright. Okay, what do you guys do to reduce this fraction? Does 2 go into 80?
Yes.
How many times?
40.
Okay, now we have 40 divided by 16. What goes into both of those? 4 goes in, right? 10 and 4. Reduce again, you get 5 over 2. That is the time. So it takes 2.5 seconds for it to reach its highest point. We're going to plug this value. Remember, that's not a height yet. That's an amount of seconds. You're going to plug it back in to this function. And you get height equals negative 16 times 5/2 quantity squared plus 80 times 5/2 plus 5. Alright, exponents go first. So what's 5 squared, guys?
25.
25
Over 4.
over 4. Hey, let's do some reducing right here. How many times is 2 going to 80 again?
40.
Okay, do 40 times 5 real quick. Go for it. What do you get? 200. Okay, let's reduce this here. 4 goes into 16.
4.
Okay. Okay, goes in here once, and -4. Very good. What's -4 times 25? What's 4 quarters?
100.
So we got -100, right?
Yeah.
Plus 200 plus 5. All right, so what's -100 plus 100?
100.
We get 100, and then plus 5 is 105, right? So that's the maximum height. Is it going to hit the jumbo screen?
No.
No.
No, because the jumbo screen's at 150 feet, right? So now we can say no. With confidence. Okay? All right, that's our video.